Hey everybody. Today we're talking about quadratic functions. A quadratic function is just a degree 2 polynomial, something like x squared or 2x squared minus 7x plus 1. More generally, any quadratic is going to have this form, ax squared plus bx plus c, where a isn't equal to 0. We require that a is not 0 because if a were 0, we wouldn't have a degree 2 polynomial anymore. It would be linear or perhaps constant. The graphs of quadratic functions are always parabolas, things like this. Now, we can learn a great deal about the shape of the parabola just by looking at those coefficients a, b, and c. First of all, if a is greater than 0, the parabola is going to open upward, as on the left here, and if a is less than 0, the parabola is going to open downward, as in the picture on the right. Notice, by the way, if the parabola opens upward, we have a minimum value but not a maximum, and if the parabola opens downward, we have a maximum value but not a minimum. Any quadratic can be written in standard form, like this: y equals a times x minus h squared plus k. The a here is the same as in the formula ax squared plus bx plus c for the form we saw a slide or two ago. The h and the k are related to b and c, or a, b, and c, but aren't exactly the same as any of them. We get this formula by completing the square. I'll run through a little bit of that in a minute. I think that the most useful way of viewing standard form is something that you obtain by transforming the graph of the standard parabola y equals x squared. First, you do a vertical stretch or compression by a factor of a. And if a is negative, that's going to flip the parabola over the x-axis. Then you do a horizontal shift by h. If h is positive, you move to the right, and if h is negative, you move to the left. Then you do a vertical shift by k, up if k is positive and down if k is negative. In particular, if you take the point 0, 0 on that standard parabola y equals x squared, that's going to get transformed to the point h comma k on the new graph, the graph of y equals a times x minus h squared plus k. So that point h comma k is going to get called the vertex of the parabola. Here's an illustration. On the left, we have the graph y equals 2x squared. The vertex is 0, 0. And on the right, we have the graph y equals negative quantity x minus 4 squared plus 1. And that has vertex 4, 1. Notice that the vertex always corresponds to the extreme value on that parabola. The minimum if the graph opens upward, and the maximum if the graph opens downward. Okay, so let's start with ax squared plus bx plus c and get that equation into standard form by completing the square. I want to run through this very quickly and not dwell on it. If you want to work through the details, you can pause the video. First, we factor out a. Then we take half of the coefficient of x and square it and add that in. And then to ensure that we still have an equality here, we subtract that same thing out. Next, we group those first three terms together and separate out the last two. And then we observe that those first three terms constitute a perfect square, and so we write them as a perfect square. Overall here, we have a times x plus b over 2a squared plus c minus b squared over 4a. This is in standard form. In particular, h is going to be negative b over 2a, the x-coordinate of the vertex of the parabola, and k is going to be c minus b squared over 4a. That's the y-coordinate of the parabola. In particular, you want to know the formula h equals negative b over 2a. It's very useful. It comes up all the time. Let's do an example. Find the vertex of the parabola y equals negative 2x squared plus 4x plus 1, and then write the quadratic in standard form. By the way, I already know that this parabola is going to open downward because that leading coefficient is negative. So let's find the x-coordinate of the vertex. H equals negative b over 2a. Here b is 4 and a is -2. And we simplify that and we get that h is 1. Now, we could use that formula for k that we saw in the previous slide, but in general, I think it's much easier to just take that value for h and plug it back into the equation for the parabola to get the value of k. After all, h is an x value for a point on the parabola. I plug k back in to get -2 times 1 squared. I'm sorry, I'm plugging in h here to get k. So I'm plugging in 1, -2 times 1 squared, plus 4 times 1 plus 1. Overall, I get 3. So the vertex of this parabola is going to be the point 1, 3. In standard form, we get that the parabola is going to be given by y equals -2 times x minus 1 squared plus 3. Here, I've plugged in the values for h and k that I know into the formula y equals a times x minus h squared plus k. And then I've taken the a value from my original quadratic, -2x squared plus 4x plus 1, and copied it down into the formula for the parabola in standard form. It's the same a value in each form. Here's a graph of that parabola. I've labeled the vertex 1, 3. Again, you can see that this parabola is opening downward. Every parabola is going to be symmetric about the vertical line x equals -b over 2a. That is, about the vertical line that passes through the vertex. Here's that same parabola again, with the vertex 1, 3, but I've added the line of symmetry, x equals 1. The vertex here is 1, 3, so the axis of symmetry is x equals 1. As with any function, we can determine intercepts for quadratics. We determine the y-intercept by plugging in x equals 0, and the x-intercepts by plugging in y equals 0. Here's an example. Let's look at the quadratic y equals 1/2 x squared plus 2x minus 6, and determine the x and y intercepts. While we're at it, we'll find the vertex, the line of symmetry, and we'll sketch the graph. To find the y-intercept, we plug in x equals 0. The computation there is very easy. We get y equals -6. So the y-intercept is 0, -6. To get x-intercepts, we plug in y equals 0 and do a short computation. Here, we can factor out the 1/2, and then factor the quadratic x squared plus 4x minus 12 to get x plus 6 times x minus 2. And now we can see that we get x equals -6 and 2, giving us the x-intercepts of 0, -6 and 0, 2. By the way, notice that I've written my intercepts as ordered pairs. Intercepts are points, not just numbers, and so you should get into the habit of writing intercepts as pairs and not just as numbers. Let's get the vertex of this parabola. The x-coordinate of the vertex is going to be h equals -b over 2a. And if we plug in b equals 2 and a equals 1/2, we get that h is -2. Plugging that value back into the equation for the parabola, I can get the y-coordinate of the vertex. In this case, -8. So the vertex is -2, -8, and that gives us a line of symmetry of x equals -2. Here, a is going to be positive, so the parabola is going to open upward. Here's what we have so far. I've labeled the 2 x-intercepts, the 1 y-intercept, the vertex, and also thrown in the line of symmetry. So now we can graph this by hand fairly easily. I'm going to draw a graph with a minimum at x equals -2, -8, so I get a parabola that opens upward. And I'm going to make sure it passes through both of the x-intercepts as well as that y-intercept.